Welcome back, everyone. This is a 1967 J45. The bridge was replaced, expertly I might add. Complete refret, also done impeccably. Super professional job. The bridge plate underneath was also swapped out. The plywood one was taken out and a solid maple one was put in. I also installed an LR Bags Anthem system in this. So as I got on the home stretch with this, I started sort of checking the intonation, and we found some trouble in paradise. Have a look at this. So here's the issue. Now, I don't know what the story was on this bridge, if it came pre-slotted. I mean, the fella that put the bridge on did an excellent job. But this is precisely why I designed my bridge slotting jig the way I did, because I never slot a bridge until it's glued onto the guitar, and I calculate it, and I know I'm going to get it right every single time. So what we're going to need to do with this one is we're going to need to fill in that slot, and I will walk you through it step by step with the bridge slotting jig and show you exactly how I calculate the perfect placement of the saddle every single time. But I wanted to walk you through this because I wanted to show you why we're going to this trouble. And once again, like I said in that 64 Strat video, this is what everybody does. Open string and 12th fret. It's about 6 cents flat. Now there's a little bit of room on the saddle here, but not enough to line this up. Let's go to the A string. It's 10 cents flat, and I've already chased that focal point to the leading edge. Here's our D string. Yeah, 8 cents flat. Again, right at the leading edge. G. 12. Yeah, 6 cents flat. All of the strings need to move forward. There's our second string. Yeah, it's also 5 cents flat, and there isn't enough room left in that saddle to intonate this, okay? And that's about 4 cents flat. Now the customer had brought this in for a compensated nut and to install the LR bag system. So before I go there, before I do the compensated nut, I want to once again demonstrate. Here's the B note on the 7th fret of the bass string. Here's the octave. Yeah, you can see it's about 7 cents flat. There's our E on the 7th fret of the A. These are new strings. And the octave, it's about 8 cents flat. D string, tuning the fretted note. Here we go, A and the octave. Whoa, that's like 12 cents flat. 3rd string, 7th fret, and octave. That is 15 cents flat. Now that string is right at the leading edge of that saddle. There is no way this guitar will ever intonate with that saddle in the place it's in. We need to fill it and reslot it. Let me finish what I started. Here's our 2nd string, 7th fret and octave. A little bit flat. That's the closest. Of all of the 5 strings, that B string is the closest. And even it does not have enough room to make the adjustment. And lastly, got that high E, 7th fret and octave. Okay, it's 5 cents flat. Before I go to the trouble of filling in that bridge, recalculating and reslotting, I wanted to demonstrate clearly why this needs to be done. Oh, I'm pulling off these strings I just put on and taking out that new pickup system I just installed, and we'll start all over from scratch. Now I do happen to have some leftover rosewood stock, so I'm going to cut this a little bit longer than I need. This is where we're going with this. So I've got my insert already made up, and just happen to have some Brazilian rosewood stock that I could do this with, fortunately. It's a pretty tight fit, but I'm still coaxing the saddle to the back edge, to this edge. So this 10 thou veneer is pushing this saddle tight to this back wall, because the cut we're making is going to be right on that glue joint there. That's where we're making the cut. I wanted to coax that saddle tight to the back wall, and that's what we've done. So we'll let that set, then we'll come back and do the math and show you where this saddle should be and how we get there. So you can see I've left this just a tiny little bit proud, so I'll sand it flush before we calculate the proper placement for the saddle and get this guitar 100% perfectly in tune. And this has to be done long before we do the compensated nut. We got to get the saddle in the right place first. Sand that flush. I've got some 80 grit here on this sanding block. This is a 3-inch block in that kit that I'm sending out to you guys. So using the sanding block to kind of hone it in, bring it in close, just about there. Just want to basically level it out. We use a razor blade. Just about there. Okay, now we're in the driver's seat. Back to square one. And we make the call on exactly where that saddle is going to be. I always run a piece of masking tape over it simply because it's a lot easier to see a pencil line on this. This is your lesson on how to find the exact placement so that all 6 strings will be perfectly in tune. There's 8 steps I'm going to go through with you here. So first step, convert to metric. I don't care if it's imperial, 25 5/8, 25 1/2, 24 5/8. Forget that. Measure the distance from the edge of the fingerboard to the center of the 12th fret. So on this guitar we measured that distance, and the distance on this Gibson was 31.25 centimeters from the edge of the fingerboard to the center of the 12th fret. So next, you double that distance, and that gives you the theoretical scale length, not the actual scale length, the theoretical scale length. So in this case, the theoretical scale length is 62.5 centimeters. For the 6th string, we take that 62.5 and multiply it by 0.097. That gives us a length of 6.0625 millimeters. This is the exact placement for the low E string. Okay, so lastly, to find the first string placement, we take 62.5, which is the theoretical distance, multiply it by 0.047, and that gives us 2.9375 millimeters. Now we can take a look at these lines. So this line here represents the theoretical distance from the edge of the nut to the total scale length of 62.5. Theoretical distance, not actual distance. So we take that 62.5, we multiply it by 0.097, and that gives us 6.0625. So basically you can round it off to 6. So this is, and I just added just a little tiny bit more. Okay, on the other side, we take this 62.5, centimeters multiplied by 0.047. And that gives us the length of 2.9375. I've actually drawn, that line here represents the actual string. So I'm taking into account the fact that the strings actually spread a little bit. So this length is a little bit longer because we're spreading the strings out. Now we're ready to cut the slot. When we're done, you'll see the remnants of where the saddle was, but more importantly, the guitar will be in tune and you'll see and hear that. So that is your compensated saddle placement lesson. I hope that all makes sense. Cheers. Okay, now that we've done the math, let me explain exactly what we've got here. There are multiple geometric challenges that you face when setting up to make a flawless cut with the bridge glued to the guitar. So this 1/8 inch right angle piece of aluminum on the bottom, it has 2 tabs of neoprene on either side. It goes in just enough to grab the guitar at the kerfing line. Now the threaded rod is covered with a stiff cardboard tube so that threads don't rest up against the finish. On the top, we've got the CNC plate that allows you to quickly set up for this cut. This is just finger tightened, no wrenches. I mean, it is an acoustic guitar. In the past, you've seen other videos where I have used a 2-footed clamp. But the engineering behind this one is such that all I do is finger tighten these fasteners, and this does not budge. It is rock solid. The other geometric consideration you need to take into account, in most cases, of course, the guitar is much deeper at the lower bout and then gradually tapers to a thinner depth towards the neck. So this jig is designed to have enough sort of forgiveness to be able to firmly grasp on both sides. So on the underside of the aluminum plate, there is a piece of hockey puck. Now this actually has a 24-foot spherical radius on it, so it's like a very shallow kind of suction cup that attaches to the top. The biggest thing that you need to watch out for here is you don't want excessive pressure. You want this thing to stay in place because you are routering out the bridge. So the thrust behind the engineering for this was to be able to do this job flawlessly, safely, and consistently precise. What you're looking at here is a plexiglass CNC'd copy of the Bosch Colt router base. And that drops in between these rails, nice press fit, and there's a centering pin here. So that centering pin basically locates the center of the 1/8 inch router bit. Here, again, simple solution to a complex problem. Those clips act as a positive stop. Long before you flick that switch on the router, you know exactly what the trajectory is. This pin tells you exactly where that cut is going to be made. This is the start point here. This is the stop point there. So now we're ready to make the cut. So I start with the cutter just kissing the top of that rosewood bridge, then I make my adjustment from there. Yeah, so I wanted to bring you in close just to show you, I don't know if you can see it or not with the camera, but the remnants of the original saddle slot. That's where, this is the back of the original saddle slot. That's how far we move forward. And on the treble side, this is the back, and that is how far forward. Now we're completely in the driver's seat. We have all of the adjustment we'll ever need to intonate this thing perfectly. So let me take this apart and explain as I go. First of all, no wrenches, no excessive force, just finger tightened. And that was enough to easily hold that in place while we routed. Other side, same deal, just finger tightened. So that, my friends, is exactly how the new bridge slotting jig works. These hockey puck pieces are actually machined to be exactly the same thickness. This has actually got a 24-foot spherical radius. So the idea is the pressure point needs to be at the junction of the sides and the top and where the kerfing line is. So this setup allows any one of you guys to do a safe, consistent, super precise job every time. This is the complete overhang. Haven't touched it yet for the A string. The low E string is done. It's perfectly in tune. So I got a 25 thou feeler gauge that I sort of protect the fingerboard with. And we cut this back. Okay, let's check it. So tune this back up. And what I'm doing is I'm fretting this 12th fret note and playing the open string. It's pretty close, much closer than it was. It's just a tiny little bit sharp, so we're gonna just breeze that again a little bit. I'll bring you in for a closer look. So at this point, you definitely want to proceed with caution. I'm just touching this. That's it. Okay, let's take another look at the tuner. And open. That's good. This is our final compensated nut, and this is the relocated compensated saddle. So that tuning check we did right at the very beginning of the video, we're going to do it again now. Okay, we're back now with the final tuning check. After the compensated nut, the relocated compensated bridge saddle, and the system has been installed. There's our 6th string and 12th fret. And then 7th fret and octave. 6th and 1st fret. 5th string and 12th fret. Open and 1st fret. 7th fret note and octave. Okay. D string and 12th fret, and then open and 1st fret. Okay. 7th fret and octave. Okay. 3rd string, 12th fret. 3rd string open and 1st fret. 3rd string, 7th fret and octave. Onto the 2nd string open and 12th fret. Good. 2nd string and 1st fret. 1st string and octave. 7th fret and octave. And then 1st string, open and 1st fret. Okay, now we can play some chords. So let's just go alphabetically. A. B. C. D. E. F. And G. So here's an asymptomatic thing that you don't have to be terrified of. so I've looped that progression in, you guessed it, A. And we're going to let that play. And I'll just blow over top of it now that this guitar is 100% perfectly in tune. And you'll hear it. Have a listen.